We're going to show you how to test SMD resistors. This time, we're not dealing with fuse resistors. We want to test standard resistors and read their ohm values so you can learn how it's actually done. Well, here you can see there are a number of resistors, and we want to find a resistor that has an ohm value and isn't a fuse type. Since these resistors are very small, I'll carefully use a magnifying glass to try and find a resistor that actually has a high ohm value. I want you to see this part, even though it might not be very clear on camera. Now, the second resistor, this one right here, let me bring it a little bit closer so you can get a better look at it. This resistor has an ohm value and is not a fuse type. And its ohm value, as I see through the magnifier, it's not clear on camera, but you can easily use a magnifier. The number 203 is written on it. What does 203 mean based on the calculations I taught you? It means 2 is the first digit, 0 is the second, making it 20, and the 3 means 3 zeros, so it's 20,000 ohms, which is 20 kilo ohms. Got it? Now we'll use a multimeter to test this and see if this resistor actually has the 20 kilo ohms it's supposed to have as labeled or not, which we'll do using the multimeter. Set the multimeter to the ohm range and test the resistor to see what value it shows us. As you can see, it's showing us 20. That 0.2 or 0.3 that fluctuates is just a very low error margin that doesn't matter at all. And it's within the acceptable tolerance, so you see it's showing us 20 kilo ohms. So this resistor is healthy. Now, if this test had shown a very low number, meaning not 20, but much lower than 20 kilo ohms, or if it showed a short circuit, meaning a very low ohm value near 0, or even a much higher ohm value, in any of those cases, we could say the resistor is faulty and needs replacement. Now, how do we test it on the board versus off the board? Well, testing resistors in general, whether SMD or DIY, is possible on almost all electronic boards with about 98% accuracy, so you don't need to remove the resistor from the board. But the off-board testing method is exactly what you've learned here, meaning we take the resistor off the board. Especially for SMD, it's harder off-board, it's actually easier on the board. Anyway, you test it off-board and it should show the same ohm value written on it. But if you wanted to test it on the board, the testing method is like this. If a resistor shows its correct ohm value like this and has no visible damage, this means that the resistor is 100% healthy and has no problem. But if on this same board it showed a higher or lower ohm or showed a short circuit, it means that the resistor is burnt and faulty and you must replace it. A resistor that is obviously damaged is one thing, but for one that isn't, you test it with a multimeter in this way. Well, let's find another resistor using a magnifying glass to see what other resistor there is. Well, we have other resistors here as well. We have a resistor that has 511 written on it, and we expect this 511 to actually be 50 ohms. We'll test it using a multimeter to see what number it shows us. See, here it shows us a very low ohm. This resistor should have been 50 ohms. But here it's showing us around 0.5 ohms, which is a very low ohm and close to a short circuit. This means that this resistor is actually faulty and must be replaced. It doesn't show any fault visually. But here you saw the multimeter showed a very low number, which was proof of its failure. Now if we test this same resistor in buzzer test mode, you'll see it'll very likely beep because it's considered one of the burnt resistors. Let me test it one more time. Well, you see it also beeps, whereas it should have had resistance. This indicates that this resistor is also burnt and faulty. We'll find another resistor. Here we have another one with 201 written on it. This means it should have been 200 ohms because the next one, the third digit, means 0, meaning 10, and 20 is the number itself. Well, we'll test it here and it should show us its ohms. Well, you see that this resistor also shows a number higher than its limit, meaning that this is also a faulty resistor and has suffered ohmic failure. It's interesting we found it on this board to show you better. It has ohmic failure and shows higher ohms. See, here it shows 480. You see that finding faulty resistors is not a very difficult task. Well, here we have a resistor with 102 written on it. 2 means 2 zeros and 10 means 10 ohms plus 2 more zeros, making it 3 zeros. So this should have been 1000 ohms or 1 kilo ohm, the resistor showing 102. Here I'll test the resistor showing 102. It should show the ohms. Of course, I'll set the multimeter to the correct range to see how it is. A little error is fine. So this means this resistor is also healthy. See, here 1 means 1 kilo ohm. Well, just like that, you can test SMD resistors. Identify the faulty one, and you can also easily identify the healthy one. Now, if a number is written, you calculate its value using the method you've learned. And if no number was written and it was a combination of letters and numbers, find its resistance using software, and you can test them very easily. Now, this also applies to resistors with color bands, and it works the same way. Regarding resistors with color bands, you perform the task in the same manner. You determine the resistance value using the colors and test it to see if it's correct or not and what its condition is. For example, here you see a resistor that according to its colors is 1 kilo ohm. And I'll test it again with the multimeter to see if it shows the correct and precise resistance. I'll place the multimeter like this so the screen is more visible. This resistor's color indicates 1 kilo ohm, and I'm going to test it. I'll perform the test by connecting the probes to its leads. You see it's showing 1 kilo ohm again, which means the resistor is healthy, and similarly, you can test other resistors and check their health. You'll see it's a very easy task and won't be difficult at all. Alright, now let's move on to how to remove SMD resistors from the board and how we can replace them. Before we remove the resistors, we need proper and good tools, because good tools allow us to proceed with the work more effectively. One of the tools we really need is a pair of tweezers, preferably electrostatic ones like these you see, and they must be high precision tweezers. Well, for instance, if I want to pick up one of these resistors, I must be able to hold it with tweezers like this. Otherwise, it'll be difficult and it won't be possible to pick up the resistor without good tweezers. Okay, I'll select one of the resistors and remove it using a soldering iron. What you need to do, which is very important when removing and placing SMD resistors, is this. You see the resistor has two terminals, one here and one there. Never ever hold the resistor this way because the two terminals you need to heat will be obstructed and you won't be able to remove it easily with tweezers. Always hold the resistor with tweezers like this as shown here so you can heat both of its terminals with the soldering iron. However, since removing these resistors with a soldering iron is very difficult because some of these SMD resistors are so small they're the size of the iron's tip, even if you use an SMD iron, the best way and one of the best methods is removing these resistors using a heat gun. To prevent damage to the resistor and the board itself, you must use a flux called soldering paste and first coat the component removal area with that paste. Now, how do we do this? For example, I want to remove this resistor from here. Well, I'll take a little bit with the tip of, say, a pair of tweezers or a knife. I'll take some soldering flux and apply it to this section. I'll coat it with flux like this completely, so it's well covered, as you can see. Hopefully it's visible in the image. You see, it's a bit oily and also quite clear, and once it's fully coated, I'll test it with my tweezers. To show you how I'll remove it, I'll do it just like this, and with the tweezers, as you can see, I'll gently lift it up. You see, it's coming off just like that. My tweezers can grip this resistor very easily. And once the tweezers have a grip, I'll use the heat gun to remove the resistor. I'm getting the heat gun handle ready. Set the heat gun temperature between 200 to 300 degrees. It shouldn't be higher, because your board will burn, and once the heater is ready, first see, I'll grab the resistor or any other SMD component. Using the heat gun, keep it at a proper distance. Note that the distance should be about 1 centimeter. For example, if this is my board, the heat gun should be placed at such a distance. See, any closer than this distance will damage the board, and then I'll remove the component. In this way, I gently apply heat to the component from above. Note that for a resistor or any other SMD component you are removing, don't pull it with tweezers. Wait until the solder is completely melted so it comes off easily. Because if you pull the component and try to force it off, your board will definitely be damaged, the plating will peel off, and if you want to place a new part, you'll face a very difficult task and you won't be able to fix that board. To repair it as cleanly as it should be, and it will be completely damaged. So definitely pay attention to this. There's no need for force or pressure, just wait. Wait for the solder to melt. Once it melts, it will be very easy to remove. I'm heating it thoroughly in a back and forth motion like this. Of course, in future sessions, we'll cover professional component removal, so you'll know how to remove ICs like these, and how to replace them. You'll learn all these topics, but for now, it's step by step. We're starting with these resistors, and I'm still applying heat until the solder is completely melted. Depending on the component and board type, sometimes a part might come off quickly, while on others, it might take longer for the solder to melt depending on the solder quality and board structure. Therefore, there's no set time, and you can't say all boards behave the same way during removal. Well, right here you can see that the SMD resistor has been detached, and I'm going to set it aside. Now I want to show you the resistor's footprint and what it looks like. I'll put the heat gun aside, and here you can see that the resistor's spot is clearly visible now that it's been removed. See? You should remove the component this way. You see, the spot has remained very clean, and it's very easy. I'll be able to reinstall a new component right here, and no short circuits have been created. The pads haven't been stripped off either. You must definitely pay attention to this and desolder components from the board in this manner. The resistor itself is also visible here. You can see that it has a very small size, and I can very easily install such a resistor once again. And just like that, you can detach SMD resistors from the board, basically remove them, and then replace them with a new resistor. Now, how do we go about placing a new resistor? For instance, let's assume this resistor is a new one and I want to put it in the old resistor's place. The first thing I need to do is to basically prepare the resistor's footprint. Now, how will the footprint be prepared? The preparation is done using a soldering iron. You must clean the tip of the soldering iron completely and then apply a little bit of solder to the component's pads. I mean where you remove the component. It requires a very small amount of solder, and you shouldn't apply too much solder under any circumstances, so that it turns out like what you see right here. Look right here. And once you've done that, you use the soldering iron to remove the excess solder. Like this. If you see that the excess solder isn't being removed well, you can very easily use a wire method, or so to speak. Use a wire and wire strands or a desoldering braid. What should you do? Remove the excess solder from here until the board is flat. And the trick I want to teach you here is that if you didn't have a desoldering braid available, you can very easily use a regular wire just like this. Just a regular electrical wire, which could be any wire. Use the wire in this manner. Now what do you do with the wire? You go ahead and coat it with soldering flux. Like this. And then using the soldering iron, pay attention to how I perform the task. You lay the wire down here on the component's pad location and press the iron onto the wire. Hold it for a bit until the wire gets hot, and very gently, without applying pressure, slide the wire across. Like this. You perform this action several times until the pad area is completely, well, flat. I'll do this again. Some pads might get cleaned in a single go, while others might require you to do this several times. Alright, once it's completely finished, you can see right here that the component's pad is absolutely flat. You can see. It's perfectly flat and ready for placement, and now I'll go ahead and place the new component. I'm getting the SMD resistor ready here, like this. If you notice the tip of your tweezers has become sticky and keeps clinging to the component, it's annoying, but you can easily clean it with some thinner. How? I'll put some thinner here and take a bit of it, bringing it up like this. And you just dip the tip of the tweezers into the thinner like so, which effectively cleans the tip, so it's no longer sticky and won't stick to the component. See? It doesn't stick anymore. I can easily pick up and place the component. It doesn't stick at all now. Look, I can pick up the component very easily without any trouble. Okay, now I'll take the resistor and I want to install it in its place. What I need to do is place the resistor in its spot like this, and first, very carefully, I'll temporarily solder one of its leads. Right here like this. To lock it in, meaning I melt the pad with the iron, so it's slightly secured and won't move out of place. You see it's positioned here so I can apply heat using the hot air station. I'll turn the hot air station back on, and as I apply heat, the component will be soldered, meaning it'll be fixed in place. I'm waiting for it to heat up to check if the temperature is right or if it's hot enough. At this distance, keep it very brief or you'll burn your hand. Hold it like this. At about 4 centimeters away, it should reach a point where you can no longer stand the heat. At that point, the station is ready, and if you have a digital station, You'll see the temperature on the digital display, and it'll keep rising until it reaches about 300 degrees. Though for a resistor, 200 degrees is sufficient to melt the solder since it's less, and you don't really want to apply excessive heat, because you might burn the board. Now, we'll heat this resistor. I'm heating it very carefully to avoid damaging the board until it's perfectly seated. Since we initially used the iron to tack the resistor down, it was just to keep it locked in place so it wouldn't move, allowing us to apply the hot air. Look, you can apply heat from both sides to do this. This heat must be continuous so the solder melts and allows the resistor to be properly installed in its place. I think that's enough, and the resistor is properly installed in its place. I'll put the heater handle back in its place. Yeah, and test the resistor. Now, how do we test it? After installing the component, we give it a very gentle tap with the tweezers on the component, and it shouldn't move at all. Well, you can see that. This component is well installed here, and just like the other components, it's placed here, as you can see. Look, right here. It's placed next to the other resistors, and you can very easily, actually in the same way you've learned, remove all SMD components like resistors or even capacitors. See, removing SMD capacitors is the same as is any other SMD component.